Good day, everyone. Welcome to Richfield Hybrid Learning. My name is Silas Toperesu, and I'm your lecturer for Mathematics 512 module. Today, we're going to look at our first syllabus topic 1, which is linear equations. On the learning objectives of this chapter, upon completion, you'll be able to develop an understanding of a clear definition of linear equations. You'll also be able to develop an understanding on how to calculate a slope or gradient of a straight line, as well as how to calculate the equation of a straight line. You'll also be able to develop an ability to understand how to differentiate linear equation and non-linear equation, and how to differentiate between parallel lines and perpendicular lines. In addition to that, you also be able to develop an ability to draw graphs of linear equations and able to interpret their shape. Let's now have a look on slope or gradient definition. A slope is a measure of steepness or inclination. Slope is sometimes referred to as the rate of change between 2 points. So whenever you've got 2 coordinates of your line, you should be able to calculate a slope. A slope is simply a change in y values divided by the change in the x values. So we have got the 4 main types of slope. We have got what we call a negative slope, a positive slope, a zero slope, and undefined or no slope at all. So we have got a negative slope in a situation when our linear equation have got an increase in the y values and a decrease in the x values. Remember, the x values are increasing as you go to the right side and decreasing as you go to the left side. So in a situation when we have got a positive slope, it's when we have got a linear equation that have got an increase in y values as well as an increase in the x values. So when you calculate a slope of such a line, you're going to get a positive slope. So we have got a zero slope in a situation when we have got a linear equation that runs along or runs horizontal along the x-axis or runs parallel to the x-axis. So when we calculate the slope of such a line, we're going to get a zero as our slope. So we have got a situation of undefined slope when we have got a line or our linear equation that runs parallel to y-axis or runs along the y-axis, vertical along the y-axis. So when we calculate the slope of such a line, we're going to get an undefined or no slope at all. As I mentioned, a slope is sometimes referred to as the rate of change between 2 points. So we use m to represent a slope in a slope calculation. For instance, if given 2 points x1, y1 and x2, y2 on a line, you may be able to calculate a slope using a slope calculation formula which says m, which is a slope, is equal to y2 minus y1 divided by x2 minus x1, which simply represents a change in y values divided by the change in x values. The formula may sometimes be written in the form of m, which is a slope, is equal to triangle y divided by triangle x, which simply means the change in y values divided by the change in the x values. Let's now look at an example that is saying, find the slope of the line through the points 3, 7, and 5, 19. So the first thing that we have to do, we label our first point as our first and the second point as our second point. So the first point is x1, y1, and then the second point we label it as x2, y2. But it doesn't matter. We can just do vice versa and label our first point as our second point, as the second one as our first point. It doesn't affect your answer. So in this instance, we label it and then we substitute into the slope calculation formula, which is saying m is equal to y2 minus y1 divided by x2 minus x1. So our y2 is 19. We substitute in the formula and say 19 minus y1, which is 7, divided by x2, which is 5, minus x1, which is 3. So 19 minus 7, it gives us 12, and 5 minus 3, it gives us 2. So m is equal to 12 divided by 2, which gives us final slope of 6. Let's look at another example, which says, find the slope of the line through the points 3, 4, and minus 6, minus 2. In this case, we labeled our first coordinate as our x1, y1, and we labeled our second one as x2, y2. When we substitute in our slope calculation formula, we say y2, which is minus 2, minus y1, which is 4, minus 2, minus 4, divided by x2, which is minus 6, minus x1, which is 3. So minus 2 minus 4, because both of them they've got a negative, and we add them, which is minus 2 minus 4 becomes minus 6, and minus 6 minus 3, it becomes minus 9. So our slope m is equal to minus 6 divided by minus 9, which gives us a final slope of 2/3. Because the negative are cancelling each other, then you are going to have a positive slope, which is 2/3. Let's look at the methods of finding a slope given the equation. If given any linear equation, there are two ways we can use to find the slope and the y-intercept. One of the methods is to rewrite the linear equation in the form of a standard slope-intercept form, which is in the form of y is equal to mx plus b, where m attached to an x is equal to a slope, and then the constant is the y-intercept. So for an example question below, which is saying, find the slope and y-intercept with the following equation, which is y is equal to 3x plus half. If we check this equation, it's already in the form of our standard slope-intercept form, which is y is equal to mx plus b. So we have got a value that is attached to an x already, which is 3. So our slope is 3. So for y-intercept, we have got a constant, which is half, which is similar to a b, which is a constant here. So our y-intercept value is equal to half. Let's look at another example that says, find the slope and y-intercept of the following equation, which is 3x plus 5y is equal to 10. So to answer this question, if you check this equation, it's not in the standard form of y is equal to mx plus b. So we need to rewrite this equation into a standard form. So to do that, we need to change and make y the subject of the formula. To make y the subject of the formula, we need to take the other term, which is 3x, to the other side of what? Of equal sign. But each and every term or each and every value that jumps the equal sign, it changes its status. So now if our plus 3x, when it jumps to the other side, is going to be minus 3x. So now we have got 5y is equal to minus 3x plus 10. But for us to left with only y here, we need to divide this 5y with 5. But when we divide this 5y with 5, we need also to divide each and every term on the right side with 5. So now when you divide here on 5y, we're left with y, then it's equals to, then we divide minus 3x with 5, and we're going to get minus 3 over 5x. Then we divide 10 by 5, we're going to get 2. So now this equation that we have is now in the form of y is equal to mx plus b. So we can simply pick up our slope. So a slope is the m that is attached to an x. So our slope of this equation is simply going to be minus 3 divided by 5, which is our slope. And our intercept is the value that is a constant b. So our value that is a constant in our equation is 2. So our y-intercept, which is the value of b, is 2. Another method of finding the slope and the y-intercept given any linear equation is by writing the equation in the form of ax plus by is equal to c. So when you rewrite the linear equation into this form, we can now find the slope by using the method that is saying our slope is equal to minus b, which is minus a, which is then a attached to an x, divided by the value of b, which is attached to a y. And our y-intercept is equal to a c constant divided by the value, which is b attached to a y. So once we write our equation in this form, we can be able to calculate or find our slope and the y-intercept. For an example below, that is saying, find the slope and the y-intercept of the following equation, which is 8x plus 11y is equal to 7. So I labeled this equation is already in the form of ax plus by is equal to c. So now we simply label our first one 8x as a, and our b and our c. To find our slope, we use the method that is saying slope m is equal to minus a divided by b. So our a is 8. So we substitute minus 8 divided by b, which is 11, and our slope becomes minus 8 divided by 11. And our y-intercept is equal to a constant divided, which is c, which is 7, divided by b, which is 11. So our y-intercept is 7/11. Now we're looking at parallel and perpendicular lines. So parallel lines are lines that are running along each other with equal distance between them at each and every point. So if we check at these two lines, these lines that are running along each other and they have got an equal distance between them at each and every point, and their slope are the same because they are parallel to each other. So two non-vertical lines with the same slope are parallel. Here are the properties of parallel lines. If two different lines have the same slope, it means those two lines are parallel. If two non-vertical lines are parallel, it means they have the same slope. Two parallel vertical lines have undefined slope. These are two vertical lines. Any line or any linear equation that you've got a line that runs vertically parallel to an y-axis, you've got undefined slope. All horizontal lines that are parallel have a slope of 0. So any linear equation that you have got a line that runs horizontal along the x-axis or parallel to the x-axis has got a slope of 0. Parallel equations have the same slope but different in y-intercept. For example, the following equation, which the first one say y is equal to 3x plus 4, it has got a slope of 3. Since this equation is in the form of y is equal to mx plus b, the slope is the value that is attached to an x. The second equation is also in the form of y equals mx plus b, which is y is equal to 3x minus 2, and you have got a 3 which is attached to an x, which is our slope. So if you check on these two equations, they have got the same slope. Therefore, they are parallel to each other. But the first equation, you've got a y-intercept, which is a constant, which is our b of plus 4. And the second equation, you've got a y-intercept of which is our b of minus 2. So these two equations have the same slope, but different in y-intercept. Let's look at this example that says, if line A has a slope of 4, m is equals to 4, then which of the below 4 lines are parallel to line A? If we check at these 4 lines below, only line D is the one that have got a slope of m is equals to 4, which is similar to the slope of line A. Therefore, we can conclude that only line D is the one that is parallel to line A, since their slopes are the same. Let's also look at the second example that says, are the two lines L1 passing through minus 2, 1 and 4, 5 and L2 passing through 3, 0 and 0 minus 2 parallel? To answer this question, we need to calculate the slope of L1 and L2 and see if those slopes are equal to each other. When those slopes are equal to each other, then we can conclude that these two lines are parallel. So to calculate the slope given 2 points, we need to calculate the slope of M1 of line 1 by saying change in y over change in x. So now when we are applying the slope calculation formula, we say consider this one as our first point of line 1 and the second one as the second point of line 1. So now we're saying 5 minus y1, which is 1, divided by change in x, which is 4, minus 2, then it becomes minus and minus is going to be a positive. So we end up having 5 minus 1, which is 4, divided by 4 plus 2, which is 6, is going to be a slope of L1 is going to be 2 over 3. So we do the same on line 2. We say our second coordinate is this one and our first coordinate is this one. So we're saying change in y over change in x. So we're saying 0 minus minus 2 divided by 3 minus minus 0. So we're going to have a 2/3 as our slope for M2. So now, since our slopes are the same, we can conclude that line 1 and line 2 are perpendicular or parallel to each other since their slope are the same. Now we're looking at the slopes of perpendicular lines. If neither line is vertical, then the slopes of perpendicular lines are negative reciprocals. If the product of the slope of two lines is equals to -1, then the lines are perpendicular. In other words, for us to test whether two lines that are crossing each other are perpendicular, we need to multiply their slope. If their slope, the result of the multiplication of their slope is equals to -1, then you can conclude that the two lines are perpendicular to each other. Horizontal lines are perpendicular to vertical lines. For example, an x-axis which is horizontal is perpendicular to a y-axis which is vertical. By definition, perpendicular lines are lines that are crossing at each other at right angle, at an angle of 90 degrees. Let's look at the properties of perpendicular lines. The slopes of perpendicular lines are opposite reciprocals of each other. All vertical and all horizontal lines are perpendicular to each other. For example, the x-axis, which is horizontal, are perpendicular to the y-axis, which is vertical. If the slope of two lines are m and the second one is -1 over m, the lines are perpendicular. For example, this line that are crossing and this line that are crossing, they are crossing each other at an angle of 90 degrees. One of the line you've got a slope of m and the other you've got a slope of -1 over m. These two lines are perpendicular to each other. To test whether two lines are perpendicular, you need to multiply the slope of the two lines. For example, saying m1 times m2. If the result is equals to -1, then you can give a conclusion that the two lines are perpendicular to each other. But if the results are not equal to -1, then you can give conclusion that the two lines are not perpendicular to each other. For example, we've got these two lines that are crossing each other at this angle. This first line, you've got a slope of -3 over 4, and the second line, you've got a slope of 4 over 3. To test whether these two lines are perpendicular, we multiply this slope of -3 over 4 times 4 over 3. In this case, we're going to get a -1, which is our result of a product. Therefore, we can conclude that these two lines are perpendicular to each other. As I mentioned, perpendicular lines have the opposite reciprocal slope. If we've got a slope of 3, the opposite reciprocal of 3 is going to be -1 over 3. For example, if we have got a line that have a slope of 3, if we want to find a line that is perpendicular to this line of slope of 3, the slope of that line that is perpendicular to the line of slope of 3 is going to be -1 divided by the slope of 3, which is 3. So to find the line that is reciprocal to the other line, you simply say -1 divided by the slope of that line. Then that becomes the slope of the line that is perpendicular to it. Let's now look at one of the examples for perpendicular slope. The question is saying, are the two pairs of lines that passes through points 5, -9 and 3, 7 and the line that passing through 0, 2 and 8, 3 perpendicular? So to answer these two questions, we need to calculate the slope of these two lines, the slopes of these two lines, and then we multiply their slope to find out whether their slopes are, the result of their slope, the product of their slope are giving us -1. In this instance, to calculate the slope, we need to use the slope calculation formula. So we label our point for line 1 as the first coordinate and the second coordinate. So now we're saying change in y, which is y2, 7, minus y1, which is -9, divided by change in x, which is 3, -5. Then 7 minus -9 is going to be a positive. So we're going to have 7 plus 9, which gives us 16, divided by 3 minus 5, which becomes -2. 16 divided by -2, it gives us -8. So we do the same for line 2 to calculate the slope of the second line. So now to calculate the slope of the second line, we're saying also we label this one as our first coordinate and this one is second coordinate. So we're saying 3 minus 2, which is change in y, divided by 8 minus 0, which is change in x. 3 minus 2, it gives us 1 over 1, and 8 minus 0 gives us 8. So this is our second slope of the second line. Now to test whether these two lines are perpendicular, we multiply their slope, which is -8 times 1 over 8. -8 times 1 over 8, which gives us -8 over 8, which reduced to -1. So now we can conclude that since m1 times m2 is equals to -1, we can therefore conclude that these two lines are perpendicular to each other. Now we're looking at the calculation of distance between 2 points. The distance between 2 points are calculated by the formula, which is saying d, representing the distance, is equal to the square root of x1 minus x2 to the power 2 plus y1 minus y2 to the power 2. So for you to be able to calculate the distance between 2 points, you need to have those 2 points. For example, the question is saying find the distance between the points 2, 3 and 1 minus 2. So to calculate this, you've got 2 points. So now we substitute this in the distance calculation formula. So you label your points as your x1, y1, x2, y2. Now after labeling them, you substitute them into the formula. So in this instance, we label this one as our a coordinate 1 and this one has a coordinate 2. So in place of x1, I'm putting 2 and say 2 minus 1 to the power 2 plus 3 minus a y2, which is minus 2 to the power 2. So now we solve 2 minus 1, we're getting 1 to the power 2 plus 3 minus 2 is going to be a positive. So we end up having 3 plus 2 to the power 2. Now we come to 1 to the power 1 plus 3 plus 2, it gives us 5. That's how we have 5 to the power 2. Now we solve 1 to the power 2, it gives us 1. 5 to the power 2, it gives us 25. And now 1 plus 25, we get 26. So now we have got the square root of 26, which is equals to 5.099 as our distance between those 2 points. So this is how we calculate the distance given n 2 points. So I need you to go through this question to try this example that's saying find the distance between the points 4, 3, and minus 5, minus 2 using the same formula that we used in our calculation. Let's look at how to calculate the midpoint between 2 points. The midpoint between 2 points are calculated by the formula midpoint is equals to x1 plus x2 divided by 2, y1 plus y2 divided by 2. The midpoint is the coordinate that is on the middle of the 2 points. For example, the question is saying find the midpoint between the points 4, 3 and minus 5, minus 2. So to calculate this, we label this at the first coordinate as our x1, y1, and our second coordinate is our x1 and x2. To answer now, we substitute these values into our midpoint formula. That is simply saying x1, which is 4, plus x2, which is minus 5, divided by 2, and our y coordinates, which is y1, plus our y2, which is minus 2, divided by 2. 4 plus minus 5 is going to be 4 minus 5 divided by 2, and 3 plus minus 2 is going to be 3 minus 2 divided by 2. 4 minus 5, it gives us minus 1 divided by 2, and 3 minus 2 gives us 1 over 2. So 1 minus 1 half and 1 half are the midpoint between 4, 3 and minus 5, minus 2. I need you also to work on this example question that is saying find the midpoint between the points 1, 3 and 4, 8 using the same formula that we used above. Let's now look at the graphing of linear equations. Linear equations are equations whose graphs form a straight line. So a linear equation is an equation of a line. In linear equations, all variables x, y are taken to have the highest power degree of 1. If we check on the below equation, which is 3x minus 4y is equals to 11, this equation is a linear equation because the x and y variables in these equations have the highest degree of 1. But if we check on the second equation, which is saying y is equals to x squared minus 6x plus 2, this equation is not a linear equation because we have got a variable x that have got the power of 2, which is against the linear equation properties. So this equation is not qualifying to be a linear equation. In graphing linear equation, suppose you're asked to draw the graph of a linear equation such as x plus y is equals to 3. You need to find at least 2 coordinates that you are going to plot on your graph. Because the graph of a linear equation is a straight line, you need to at least 2 points that you are going to join and then you extend your straight line. So to do that, you need to find at least random numbers that you are going to substitute into this linear equation and able to find at least those 2 coordinates. To solve this equation, we can start by finding the y-intercept. Y-intercept is where the graph crosses the y-axis when x is equals to 0. So we substitute the value of x is equals to 0 in our equation here. Then we solve for y. When we substitute 0, we're going to have 0 plus y is equals to 3. And then we have the value of y as 3. So now we've got one of our coordinates, which is 0, 3. So we go on looking for another coordinate, that value of x or y that we're going to substitute for us to find another second coordinate. Now we'll look for another random variable. Let's say x is equals to 3. So when we substitute x is equals to 3 in place of x here, we're going to have 3 plus y is equals to 3. And the 3 will jump to the other side because we're solving for y. When the 3 jumps to the other side of equal sign, it's going to be 3 minus 3. Remember, any number or any term that jumps to the equal sign will change its status from positive or from negative. So now we're going to have our final value of y as 0. And now we have got our second coordinate, which is 3, 0. And now we go on substituting another random variable. Either now we're substituting the random variable at y, and consider variable of y as 6. So when you substitute in our linear equation, say x plus 6 is equals to 3, then 6 is jumping the equal sign to the other side. So we're going to have x is equals to 3 minus 6, and 3 minus 6 will give us the value of x as minus 3. And now we have got the third coordinate, which is minus 3, 6. And now we have got at least 2 coordinates, which is 3 coordinates that we have. We now go with these coordinates to our graph and start plotting them. Since now we have our 3 coordinates, we go with these coordinates to plot them on the graph. So the first coordinate is 0, x0, y3. x0, y3 on our graph is the y-intercept. So x is 0, y3 is this coordinate that is here. And now we look for the second coordinate, which is x3, y0. x3, y0 is going on the positive side of x-axis, which is x3, y0 is an x-intercept. So the third coordinate is minus 3, 6. X minus 3, we are going on the left side of 3 units, going on the left side of x-axis, and then going up 6 units on the y-axis. So this is the coordinate minus 3, 6. And now after plotting these coordinates, we're simply joining these 3 coordinates with a straight line that is extending, going down and going up. And this line is our graph of the equation x plus y is equals to 3. Here are some exercise questions to test your knowledge and your understanding. Draw the graph of these 3 linear equations. Start by finding the coordinates, at least 2 coordinates of each, and then go and plot them on the graph as we did in our previous examples. Now we come to the end of our first chapter for linear equations. Thank you all for being part of Richfield Hybrid Learning Program. I hope to see you all in our next lecture.